Hello, everyone. Good morning. Thanks for joining the session today on time. Really appreciate it. So digital transformation is really a key takeaway now on everyone thinking. And also from our organizations and SPIS especially, they are trying to digitally transform in one way or another. Transforming into digital transformation or digital world or digital era, along with the autonomous network is very crucial. And in today's session, we are trying to give you some reflections and insights on one of the most successful transitions that we have seen in Middle East. And this is for a leading service provider in United Arab Emirates. It's du-Telecom. And they have very concrete and focused and structured plan and vision for the digital transformation and the autonomous network. My name is Tawfik. I'm a software solution architect, part of the SP architecture team. I had the honor to lead the automation engagement for the last 4 or 5 years. And today, we're going to give you a bit of reflection and lesson learned that we have seen from real world example. The beauty about this session is it is not a theory session. It is not a POC. This is something that have been there for the last 5 years. And we are trying to show you what have been working well, what have went well, and what are the best steps or steps that you can take to achieve this kind of scale automation and the autonomous transformation. So our agenda for today is a bit simple. We are going to explain first what have been done on the last 5 years from do perspective, what are the kind of use cases, what are kind of strategies that have been implemented with do. And also we are going to focus on how we was able to deliver this transformation and this transition into do, supported by Cisco CX, and how Cisco CX was able to help the customer to achieve the vision and the goals that they are aiming for. And last but not least, the BVR, so the business value realization, which is the main fuel of the customer to be able to continue investing and working towards the goal that they are aiming for. Okay, so as you have heard multiple times, automation is a journey, but we need to identify some milestones just not to get bored while we are on this journey, right? So the automation starts normally small scale, simple tasks, small teams, and this is what we have seen in most of the accounts. So we start with task automation like simple activities like port turn up, interface configuration. There is multiple, these are the normal day-to-day activities that the teams or the organization is trying to automate at the beginning. And then we move to more complex automations like, for example, device automation like ZTB, zero-touch provisioning, any kind of these bigger scale use cases. Then we move to the next stage, which is the domain automation. So the customer, for example, identify a specific domain or a specific entity that they want to automate, for example, like mobility automation or enterprise services or access domain that they want to automate. So they start to identify what are the use cases that will be able to achieve this goal. And then in order to be able to achieve this goal, we found out that to be able to have this end-to-end vision or end-to-end automation, we need to touch multiple domains. So we move into this multi-domain orchestration where we have multiple devices in different domains are being automated as part of this end-to-end vision. The ultimate goal that we are trying to achieve, and this is what we have done at Do, is the business automation. So the business automation is the main fuel for the automation in general. Business is the main objective that we are trying to automate. So from the customer perspective, they want to be able to provision services in a simpler way, in a faster way, and more organized fashion. So this is the automation architecture that we have ended up with at Do. Of course, we didn't start at this scale. We have started very simple with only NSO. We have automated only single use case. This is back 2017 for ZTB. And by the time and setting the vision with the customer, we was able to transition and upgrade this architecture into what you are seeing now. So we see here mainly 4 boxes or mainly 4 components. We can see Cisco SPIS, and Cisco SPIS is a CX product which we normally use for the custom GUI development. So as part of our journey, we have emphasized on the customer experience and the easiness of use. That's why we have developed a custom portal for the customer for all the use cases that have been implemented, and we call that Unified Operation Portal. It is unified because it is single pane of glass. All the teams from different domains, they are able to use this single portal to communicate and deal with their use cases. SPIS also comes with out-of-the-box capabilities for AI and analytics, and we have also used these capabilities for some of the use cases that have already implemented on production. Cisco BBA is our workflow engine, and this is important when we talk about value delivery or business automation, because this is what stitches these different use cases that you have automated together, right? This also allows us to do approval cycles, it allows us to do multi-step provisioning, and so on. It also contains the API gateway, Kong platform. Both BBA and SPIS, they are microservice-based architecture, so they come up equipped with some of the tools that we use from time to time. So here, for example, Kong API, we are using it to be able to expose all the APIs that we are automating, all the use cases that we are automating to the northbound system, compliant with TMF forum, so we can expose these services to the northbound systems. Cisco NSO is, of course, the main component in this architecture, which allow us to do the service provisioning, service pooling, and network discovery, and all kind of network touch points. As you can see, also we have Nokia NSP and other EMSs and NMSs from different vendors, and we are able to communicate with these elements to be able to provision services to these devices if you are not communicating with them or managing them directly. Cisco Accedian is a recent addition to the automation stack, and the purpose of Accedian, as you have heard in different sessions previously, that it is using for the probing and to be able to test. So Cisco Accedian, as I was saying, that this is the recent addition, and we have been adding Cisco Accedian onto the automation to be able to do what we call orchestrated assurance. In other terms, that we are not only provisioning the services, we are not only configuring the services, but we are also making sure that these services that we have automated will be matching the agreed SLAs and QoS profile. So Accedian has different type of testing. They have virtualized SFPs, they have hardware SFPs. So and it's very capable because one SFP can initiate up to 2,000 sessions, right? So we don't need big number of SFPs. We are able to cover most of the network with a small number of SFPs. Downside, you can see the network, and you can see here different domains from DC, from transport, mobile, IGW, and all these domains have been already penetrated. All of these domains have been already, we have delivered use cases on these domains, stitching them together to be able to achieve the end value or the end-to-end automation for the different verticals. Okay. So here we are also trying to summarize the domains that we have already automated. As we have explained, this is our Cisco automation platform. As we explained, Cisco BBA, NSO, SPIS, and Accedian. And this automation platform is responsible to automate use cases into different domains, from access, transport, core, RAN, DC, and also we are starting new use cases like, for example, APM provisioning for mobility, 5G slicing, and technical cloud related use cases. By this architecture and this automation stack, we are able to achieve service provisioning, we are able to achieve migration services, we are able to achieve assurance, observability, which will be discussed in details and explained by Telmo on the next section. This slide summarizes the use cases that have been achieved so far. We are exceeding actually 50 use cases so far. Most of these use cases are already in production. As we mentioned at the beginning, the idea of automation is not only to develop a use case that will be serving a specific purpose. The idea of the automation and in this journey, you need to put in mind that these use cases will meet up in one point of time, right? And these use cases will need to be stitched together to achieve this value delivery that we are talking about. So for example, for enterprise services, we identified what are the services that need to be automated for the enterprise domain. We have automated all the services from A to Z. We are not only automating the service provisioning, but also we are seeing how these services could be used, right? So what we have achieved in enterprise service, for example, domain, from the access switch, we are able to identify how these access switches are connected to the network, which BDS is connected to, is it which topology that this access switch is part of, and you are able automatically to identify the configurations that need to be pushed to these several elements and network devices, either they are Cisco devices or multi-vendor devices. At the same time, also on the IGW, for example, we have automated all the use cases related to this domain, right? So we are not stopping automating in one domain unless we are able to finish all the use cases on this domain. So operation team, the relevant team members are able to use these use cases into day-to-day activities, and they are not doing any kind of manual activity afterwards. So for IGW, for example, we have automated the BGP optimization, prefixes manipulation. We are able to automate the resolution of congestions on the peering links. Either these links are transit peering links, private peering links, and so on. And also we have automated the provisioning of these peering links to the customer, right? I'm not going through all the details. This is a big number of use cases, as you can see, but there is one important point, which is business process automation. So now we are not only automating network services and the use cases, but also we are automating the processes. Very simple processes, very absolute processes. It's not touching the network. So for example, we are automating the OLT rollout planning, right? So we identify who are the stakeholders, which teams are engaging together into the normal process to automate these, to plan for these activities. We stitch them into a workflow process, and every team is giving the input, and we are able to enforce SLAs that to be able to restrict the time that it takes to plan for these activities. So this is the Unified Operation Portal. As I mentioned, we call it UOB. And as you can see on the left side, you'll be able to see different domains, like from enterprise to IGW to infrastructure and so on. And this is, of course, based on the RBAC system. So teams from IGW, for example, they will be able to see only IGW-related use cases. Infrastructure team, they will be able to see infrastructure-related use cases and so on. And using SPIS Grafana, one of the capabilities that we have on SPIS, we have built multiple dashboards for the different teams or different use cases that enables the team to have a single look and comprehensive information about how the use cases are performing and if there is any issues that have been identified. One of the main lesson learned that we have seen also in do account is the importance of adoption, right? So implementing a use case and putting it on the shelf, this is not helping anyone. This is not a good reputation for Cisco. This is not good for the planning team who decided to have this use case. So the customer and ourselves is trying to make sure that these use cases are being used efficiently. We are trying to streamline and enhance and make it as much as we can flexible and easy to use for the teams. We are trying to engage the team from day one, the stakeholders from day one, so they can give us inputs and the ideas of how these use cases need to be added. We have also implemented dashboards to show the adoption to the executive team, right? So they are investing big amount of money, especially on this account. So they want to see the return on investment. They want to make sure that these use cases that we are investing on are being used, right? So this dashboard, this is a real data that being presented to the executive and the management at Do, and it shows the number of transactions that have been done on each of the use cases on daily basis. You can see also some red flags or red color because this is real time. So some of these use cases, for example, indicate that there was outage or there is a device connectivity issue at one point of time, and Telmo is going to give us a few details about observability and what we have done on this domain in more detail. Just to wrap up the overview for Do. We have been working on this account, as I mentioned, for 5 years. This is one of the biggest automation engagements for Cisco CX. We have more than 80 engineers working on this account. We have been increasing the number of Scrum teams until we have reached 10 Scrum teams. These teams are working in parallel. They are working on different domains, dealing with different stakeholders. And each of the Scrum team has a tech lead or a product owner. They work with me as a product manager to be able to plan and design the use cases, and then they take it with the development team to be able to execute. We have done already 200 sprints on this account, which is a big number. And I'm going to, in the next step, I'm going to, or next phase, or next item of the agenda, I'm going to explain how we have delivered this amount of sprints, how we are able to automate and deliver this amount of use cases using a scaled agile framework. We have done 50,000 hours of code development, and based on our team capacity, each use case almost took 2 sprints to 2.5 sprints, which is average time for the implementation. Of course, we are emphasizing on the importance of DevOps and CI/CD. Without CI/CD, using all the tools like Jenkins, GitHub, SonarQube, all of these tools that help us to automate and deliver use cases to make sure that whatever use cases or feature that we are delivering to the customer is not breaking any of the previous, and we are making sure that regression testing is always a trigger to make sure that we have a consistency on our delivery. Value delivery approach. So we have already discussed what we have delivered. Now we are going to discuss a bit more about how we delivered these deliverables to the customer from use cases and value. So what we call it scaled value delivery model, and this is coming from the scaled agile framework, or SAFe. Scaled agile framework is the, we call it a scrum of scrum, right? When you have big number of scrum teams working in parallel, delivering use cases in the same time, you need to have an approach that can manage the execution and the delivery of these teams. That's why we use scaled agile framework, and for scaled agile framework, we are planning not for the next months, we are planning for next quarter, next 3 months. So we identify what are the objectives, we sit with the customer to identify priorities, and so on. And one of the most important things that we do in the workshops of the PI, we identify the themes, right? So what is the theme that we want, or what is the main achievement or goal that we want to achieve by the end of this PI? And we split this into smaller initiatives, and from smaller initiatives to use cases. And these use cases will be translated later into a backlog. This backlog will be well identified, well estimated, well documented, and then it will be on executable backlog that can be executed during the normal sprints. So here we focus on, we deliver the value. As we mentioned, we see the use cases, what have been delivered before, what we are going to deliver next, and how these use cases will be stitched together, right? We don't want to deliver every PI a single use case or a use case that is in silo working in different world, right? We're trying always to build a story over time. So at one point of time, we will be able to stitch this theme or this domain end to end, like the example that we are going to show in the next slide for the mobile delivery. The last step, which is measure. If you cannot measure, you cannot enhance, right? So this is what we are doing with the Grafana and the different dashboards that we are delivering to the customer. This is one quick example of the mobile automation theme. So as we mentioned, themes are split into initiatives. Initiatives is to split it into use cases. And this is one theme of the mobile automation. So what the customer wanted to do, he wanted to automate all the processes and use cases related to mobile domain. He doesn't want to touch the mobile domain in any means manually, right? So what we have done, we have identified what are the stages, what are the steps that the customer is taking today to be able to deliver or to plan or to execute a new site, new cell sites, CSGs, right? So we have identified that there is a planning team, there is a physical deployment, there is IP connectivity, there is site transport, RAN commissioning, and then testing, and then acceptance, right? We have also set with each of these teams, we identified what is the time it takes the team to execute and do all each of these processes, and we found out that this is taking almost or average 60 hours, right? Then we move to the next stage where we have tried to think about how we can automate these stages. Can we develop use cases that can replace this manual task? Can we even automate the processes from work using the workflow engine? And we found that there are possible use cases. So we identified, for example, a use case called cell site rollout, which is very standard workflow that just stitch these different teams together for the planning to give the inputs. And then we have also identified the CSG ZTB for the cell site gateways. We have identified mobile provisioning and migration, which is the actual service that provision the mobile services like 2G, 3G, 5G, all the services, plus migration. We have also identified RAN ZTB, and at the end, we have also automated the process of acceptance. Once the vendor, for example, Nokia or Cisco or Huawei, they provision new CSG site, what is the procedure that they take so can accept this new site? After automating these processes and stitching them in one business process, we have dramatically decreased the amount of time required from 60 hours to 7 hours, which is almost 88% optimization. Again, this is how we implement, as we mentioned, from roadmap, strategic objectives, backlog, program backlog, review and approve which of these features or use cases will be executed. The PI plan that we do with the customer every 3 months, we identify the priorities, and then we translate these priorities into executable backlog, which will be the sprint execution. Last section, which is most important one, again, the value realization, right? How we can make sure that these use cases are really bringing value by benchmarking. We need to measure before and after the automation. These are some examples that have been also demonstrated on the last Cisco Live in Amsterdam. And these numbers that we came from the customer, these before automation, this is the number that we got from operation team mouse, right? We didn't even challenge. We know for a fact that, for example, mobile service provisioning, it doesn't take 15 minutes. We know it takes maybe 4 hours, right? But however, we didn't argue. And after the automation, you can see the difference, right? You can see more than 48 faster time. You can see, for example, in the ODR reporting, which is very simple use case, which is doing the impact analysis for, so OER is a simple use case just to do the impact analysis. Whenever we want to bring down one device, the customer wanted to know who are the customers, who are the which services will be impacted when you bring out this device. So this used to take them 3 weeks, right? We did it in 30 minutes. So this is 240 times faster than before. Last slide. This is another simple use case, and this is very important to start with the smaller use cases that has high frequency or high impact, right? The customer will not wait for you for 6 months to deliver one use case or 1 year, right? This use case was able to deliver in maybe 2 sprints or 3 sprints, and it simply suspend the internet service for customer who didn't pay the bill for the last 3 months. As simple as that. So the customer used to take 15 minutes to suspend the customer, trying to find which device, which contract ID, which QoS profile that he wants to suspend, and then suspend the service. After the automation, the customer easily can go to the portal, search with the contract ID, press one button, suspend. So from 15 minutes to 2 minutes, so with simple math, this is 13 minutes saving in each transaction. After the first months of rolling out this use case to production, this have been used more than 1,700 times, right? So if you multiply 107,000 times by the 13 minutes, this gives you almost 400 hours of saving, just from one use case that we took 2 sprints to automate. Yeah, that's it. I don't have time for this one, I believe, but it will be on the slides. Just the key takeaways. Start small and with the most impactful use cases, as I mentioned. Deliver in cadence. You need to put in plan the ultimate goal that you want to achieve. Engage the right customer evangelist. This is one of the most important things that we have seen and makes the success of this account. We have been dealing with Ahmed Suleiman. Ahmed Suleiman is the transport and planning director. He is very well educated and understand what is the automation value, and he helped us a lot. Showing BVRs is the biggest supporter, as we have mentioned, and understand the customer priorities and work on these towards these priorities. Thank you so much. If you have any questions, I'm here.
Hello. Hi, Amr. So you mentioned the importance of the adoption and production of these use cases, and you're giving good advices and insights here. Is there any situation that you could share with us of when that adoption in production did not go so smoothly, and then how did you deal with it?
Yes.
What kind of lessons learned you had from that experience?
So in multiple domains, what we have seen that, or the mistake that we have made at the beginning, that we was not engaging the right stakeholders from early enough, right? So we found out that, for example, when we reach to the ATB phase, there are some people that we see them for the first time, and they see us for the first time, and they see the use case for the first time. So they have different expectations, different understanding, and they are the main stakeholders. They will not accept the use case in production before their suggestions or these requirements will be implemented. So adoption is a key, and if you want to have high level of adoption, you need to engage the right people from day one, during the design, during the implementation. Yeah. Thank you.
Is it on now? Yeah, great. All right, so my name is Telmo Santos. I'm a software architect, and today I'll be telling you about the Do Automation Observability Stack. It's a continuation from the presentation that Amr gave about the Do Automation project. And I'll be focusing on monitoring, log aggregation, and insights extracted from those logging and monitoring data through GenAI LLMs. So here's the agenda. I have just a couple of slides for introduction. Then there are 4 sections, one section for each one of the observability components that we have onboarded already. And then at the end, I'll wrap up the presentation with a summary and some key takeaways. So starting with the introduction, just a few words here about the high-level architecture of the Do Automation project. You probably got the idea from Amr that this project is a large-scale project. And on this slide, I'll try to show you that this project has complexity at many levels. One of the levels of complexity is at the amount of use cases. There are more than 50 use cases in the project. Then regarding the automation components, we have one NSO, but it's not just one. We have 2 NSOs. We have a second NSO for the data center track. Towards the northbound, we have Cisco SPIS as the main automation portal, and we are also using Cisco BPA for the workflow capabilities. So we have some complexity here, and I'm not even adding the Ascedian integration that will come very soon now as well. Regarding infrastructure and deployment, NSO it's a single server deployment. SPS and BPA are Kubernetes deployments. So we have a Kubernetes cluster, we have a database cluster. And so that means that there are many VMs on each one of these components. And then we multiply all that by 2 because we have GOAJ in our solution. So complexity at the infrastructure level as well. Regarding external integrations, I'm just listing some of them here, but there are many of them. And we need to ensure always that they are available, that these services, that we can connect to these services and everything is okay. Towards the northbound, we have many operations and planning teams that access the portal to configure and trigger the use cases. But we have some programmatic accesses to our automation cluster as well through other orchestrators. And then, of course, towards the southbound, we have the complexity on the network. So I just spoke about all of these different levels of complexity. And this is really one of the most important whys of observability. We have so much complexity. How do we ensure that all of these components are active and are reachable and they are talking to each other as they should? So that's why we need observability. And what are we exactly looking for in observability? We want to have real-time visibility of what is happening. We want to avoid problems if we can with proactive maintenance. If we cannot avoid them, we want to troubleshoot them fast. And then we also want to ensure that we have a good resource utilization in the automation cluster. And so then we enter our observability journey. And this is a representation timeline of what happened throughout the years. And you will see the different components that we added and how they return value to us in terms of observability. So we started with a really small component called reachability monitoring. This is something that is just checking periodically if different services are active or not, reachable or not. Then we added Prometheus server and NSO monitoring. After that, log aggregation with Loki. And then with all that data, we started to think of the best way to extract insights from it. And now we have an ongoing POC of which I'll show you some results, some interesting results, using GenAI to extract those insights. And towards the future, we are planning to onboard OpenTelemetry with Jaeger. And this relates with the observability exporter module from NSO, and also relates with the presentation gave by Roque Galliano on Tuesday regarding OpenTelemetry as well. So this follows the chronology here of the presentation. I'll be talking about these 4 main components. For each one of the components, I'll follow the same sequence. I'll tell you why we decided to use it. I'll tell you about the high-level architecture. I'll give you details about the configuration and some of the features that it has. And I will
wrap up each one of the components with a true story from production so that you understand where we extract value from it, and hopefully you will see value on it for your cases as well. At the end, and before just moving to the next slide, I would like to keep in mind that for us, in this journey, we always had to make a decision on what would be the best choice to maximize our observability value and reduce the amount of effort or risk that we need to put into it. And I think both case of Prometheus and Loki, on those cases, we really hit the nail on the head, because we didn't use any coding. It was just configuration, and we didn't add any compute resource. We just used what we added. So small investment and big output of value. So let's talk about the first component, reachability monitoring. Why we need it? Well, we just spoke about the complexity in the cluster. We learned the hard way. We learned that sometimes a single component can cause a large disruption on our network automation cluster, and we needed to be notified if something happens. We didn't have that from the beginning. So the first I want to tell you about the high-level architecture of the solution. Again, as I said, fairly simple. If we want to monitor something, we give a curl command, and then we just say which one is the HTTPS code that we expect, and some keyword that we are expecting also to see from the output of that curl command. So once that is configured, the system goes, and every few minutes, it goes and pings and checks the reachability to the different targets. And the result of that is stored on our database in Postgres, and we have some dashboards to show that over time. Additionally, we also have a type of event-driven notification where we detect the cases of when a system or a service has become reachable from unreachable or the opposite, and we notify a distribution list with that. Very quickly here on the configuration, this is the UI that we have. It's simple. You give it a name, define the curl command, the code, and the payload that we are expecting to see. If we have a match, it's reachable. If we don't, it's unreachable. And then once we have the data, we can open the dashboard and see the reachability status of all these different systems. Of course, if it's green, it's reachable. If it's red, it's not reachable. And then there are some emails that are sent when there are changes, as you can see down there. So those notifications are just represented here. This is an example of an email that I sent with this event-driven logic behind it. Finally, regarding reachability monitoring, I want to tell you a real story. This is from our production systems. In one occasion, we were seeing degradation in actually some of the use cases. We came to the dashboard, we opened it like this, and we saw that at a specific moment in time, we had 5 different services outside of our automation cluster that started to have this intermittent outage at the same time. So then this quickly allowed us to understand that the problem was not from the automation solution. We shared this with the customer, and then it was found from the infrastructure side that this had been due to a data center network misconfiguration. But the idea here of the value, towards the value, is that the time that it took from us to identify the issue, to actually understand that in this case it was not related with our automation, was very fast. So this is where value is coming from. Now let's go with a second component, the Prometheus service and NSO monitoring. Why we need it? Well, we also understood that the server performance is changing over time. We had some cases, and I will give you an example of that, where the VM resources were actually reaching their maximums. And we wanted to have a way to track the usage of different NSO packages. So the high-level architecture here is based on a configuration of Prometheus. In the next slide, I'll show you this configuration file. It's quite simple. You just tell Prometheus which ones are the servers and the ports of which exporter processes Prometheus should scrape every, let's say, 1 minute. So this is just a representation of a Kubernetes server, representation of an NSO server. For the Kubernetes server, we have statistics for the server itself, statistics for the processes, and specific statistics for Kubernetes. Something similar here for NSO. But we have these 2 exporters, these 2 processes that are listening on a specific port, that are collecting statistics, in this case, specific of NSO packages. And these are internal metrics of NSO. This one is only available on NSO 6. And by the way, these two components, they were presented last year on this conference on that day. So we saw the presentation. We had access to GitHub, and then we just adapted that and we integrated that into our solution. So once these statistics are collected, Prometheus is storing them on PromQL, and we also have dashboards to visualize them. Just a few insights here on the configuration. It's quite straightforward. From the top of the configuration file, you can see you can define the scrape interval to say how often you want to make the scraping, and then you just need to say what is the IP and port of this exporter, and then the exporter will get the request, will collect the statistics, and send it back to Prometheus, and then just store it on the database. So again, no code needed. You just need to configure these targets. Once it's configured, Prometheus allows you to see the status of each one of these targets or these components that are being monitored. You can see the state in green. If it's up, it will tell you that if something is down, or it's either connection refused, or sometimes can be timeout. And you can even see the scrape duration in case you're worried that this monitoring process you think might be taking too long, or itself is consuming too many resources. You can see here how long it takes to scrape the data. So now that we have all the data, we can visualize it. So from the top there, top left corner, we have the node exporter with the statistics of the CPU, process exporter. So these are process operative system specific statistics, process statistics. And these two down here are the ones related with NSO. So we can see the usage of different NSO packages over time, and metrics of NSO as well. Has the session and commit queue, etc. So for this component, we also have some real stories. So in this case, we had identified that one of our servers had 100% CPU utilization. We came to the dashboard, we adjusted the timeline, and we saw that actually the CPU utilization had been increasing progressively in the last weeks. So it was not something that was just momentaneous, that was in that moment. And actually, this was then identified to be caused by a third-party agent installed by the infrastructure team. And you can see here the moment when it was restarted, and then it started to do the same thing again. And after this, it was agreed to just disconnect and to disable this agent in one of our servers. But again, the idea here is that this type of visualization allowed us to interpret the behavior of this agent. And it gave us more confidence to know what we needed to do. And we could also track what it was trying to do again. Okay, and it has a second real story. I want to show you here the visualization of utilization of different NSO packages over time. We have 50 different use cases in Do, but actually these 50 use cases, they map to more than 70 packages in NSO. So there's a lot of stuff that can be used. And we can see over time, you can see some periodicities here. And we had a specific case where a specific NSO package should be called every 5 minutes. By looking at the chart, we identified that we had these peaks every 10 minutes. And so we identified from that, this information, that we had a misconfiguration on the process that was calling it. So we corrected it. It was moved to 5 minutes. And then so we fixed this problem based on these insights. And for me, as the product owner of some of these use cases, I need to have access to this information. I cannot just put a use case in production and forget about it. I need to be sure that that is being used. I also need to know how frequently it's being used, what is the resource consumption or the impact, for example, in NSO. And I also need to know who is using it. And later on in the presentation, I'll try to show you how we try to extract all this information automatically using the LLMs. All right, moving to log aggregation. Why did we need it? Well, we wanted to have a solution where we have persistent log storage. We also have a large number of log files. They're all with different formats. We are not, in many of our components, we are not really following specific log format. And then we have a difficulty tracking logs from one system to the other. You saw SPIS, NSO, BPA. It's so difficult to track what's happening from one to the other. So in terms of high-level architecture, contrary to Prometheus, here is the opposite. We have is not a listening agent on the target system. It's actually it's not a listening process. It's actually an active agent, prompt-tail agent, that is monitoring the specific log files. And if nothing is happening to the log files, there's nothing that is sent back to the server. But if those log files are updated, if there's new lines of text there, then the prompt-tail agent automatically sends it to Loki, and then Loki is storing it on the logql database, and we also have dashboards to see that all that data integrated. So next I will show you some quick configurations here of the prompt-tail YAML file. So also quite simple here. We just need to say where are the files that we want to scrape or to monitor, and that we can use regular expressions to get access to identify multiple logs, and we tell it where to push the data. So this is where the Loki server is listening and waiting for this log messages. Then once we have all this data, we can see the log messages being or changing, or the amount of text on the log messages changing over time. And we have a single plane where we see messages from different logs. And there's even some basic identification and tagging that log is doing, identifying errors and putting them in red, or info to be green. So it gives us this type of visibility. In terms of the real story here for the log aggregation, I would like to tell you about this specific error that we were seeing in our front end. It was a 400 client error. It was not very descriptive. It was just saying, okay, we get this error towards that API. And what we did was we went to Loki. We searched for that error message. We found the error message down here. And then Loki allows us to see all the previous messages from all the different logs, even from different systems, because it's centralizing all this log collection. And this was very valuable to us. So we can see here from the top that the portal where this error was happening was, it was saying that it's triggering this call to NSO. Then we see the NSO audit log confirming that there is an external access to this action. We have the package log in NSO with the different messages, and we can see down here the reason for the problem. Device is logged in the sync from operation. So it allowed us to quickly see all of this without having to go to the servers and search in the logs and match timestamps, etc. Now, at this point, it's important to remember that Roque Galliano, in his presentation, he told us about using OpenTelemetry and how by using OpenTelemetry, there are some IDs that you can use to track a request from one system to the other. And then he showed that, some graph of that with Jager, what was quite nice connection and interpretation of the request. So here we don't have that, right? We don't have that, but Loki allowed us to have this complete view organized by timestamps. And part of the beauty of this, at least, is that we did no change of code on SPIS. There's no specific rule on the log message that we are using. Actually, some of this code has many years, and we prefer if we don't need to change anything. So even though maybe we don't have the full capability of OpenTelemetry, which we want to go into that direction, this was something that really required small effort, and this gives us a lot of value to integrate and to see all these logs together. All right, so we spoke about the data of monitoring and the need to, as a product owner, to be able to understand what is the usage of the packages that relate with my use case, and also this data that we have and that we can use for the logs. So then we started to think how we can extract this insights in a better, more automated way. So we wanted to have automated way to extract the insights. And for me, I think it's quite important to be able to have this human-like interaction to analyze data and insights. Because of course we can have some threshold crossing alerts, but often the interpretation of how a use case, for example, should behave in production, maybe only that I'm the product owner knows about it. And maybe I want to ask different questions, I want to go deeper into something. So this interaction, the human-like interaction, it's important. So we started to work on this use case. It's a POC. I don't have a demo to show you, but there are some details here of their architecture and most of the tests that we've done with Bridge IT, which is the enterprise version of ChatGPT-4 that we have available in Cisco. And this architecture is not very different than what you've seen in the previous sessions on this conference. So we have a user connecting to a WebEx bot, and then on our backend we have this, we can call it observability agent with retrieval augmented generation capabilities. So the agent will interpret the question that comes from the user and will take into account the data that it has available in terms of even charts, Prometheus data, monitoring data, or Loki. And then it will build a prompt down to the LLM service to request this insight. And then we can have this conversation between the user and the LLM through the observability agent. So again, as I said, we don't have like a demo here to show you, but I would like to show you some results that we found to be quite interesting on the capabilities that these LLMs have. So starting with this data, again, this is data of NSO package utilization over time. You see different colors for different packages. You see there the NSO, the NCS process, and then other packages here. And you might identify visually that there's some periodicity on the blue line and on the red line. You might even identify that the red line over time seems to have kind of an onset, is kind of growing a bit. And we wanted to identify if the current state-of-the-art LLMs, the ones that we have available, if they're able to detect and to provide insights on this or not. So the prompt that we created, from the prompt that we created, we get such an output. So regarding periodicity, and we're just giving it a bunch of numbers. It's basically just a big table with timestamps and numbers. And we are asking the LLM, do you find periodicities here on the data that we see here? And it does so. So there appears to be a periodic pattern in the utilization of the NCS and BGP transit peering optimization with intervals that could be around 5 minutes. So this is exactly correct. This is exactly what we see here. And we also ask it to try to see if there are trends. And it says, regarding trends, unlike the NCS, which is the blue line, the utilization seems to be increasing with each cycle indicating an upward trend, which is exactly a very good interpretation of what is happening here. So this for us, it tells us that Bridge IT, or the enterprise version of Cisco of ChatGPT-4, has good data analytics capabilities. And this was something that was not evident to us. I mean, we know that they are good at text, but if they are good at interpreting data like this, just interpreting numbers, that was not clear to us. So it was a good insight for us on this. Then we also wanted to know the other type of data that we have on observability is these logs. Can it interpret logs? Is it capable to interpret logs or not? So the prompt that we had in this case was, we were just providing some the audit log from NSO. We were not explaining anything about the format of what exactly is on the log. And we were just asking, can you please tell me which one is the user that is mostly using the specific package? So I see some kind of weird behavior on the package, I can ask, who is the user that is using it? And maybe I don't want to go to the audit log. I want this to come directly to me through WebEx. And the output was, as you can see here, based on the log messages provided. It appeared that the user with a username BGP admin is the one accessing BGP transit peering optimization package using REST-conf APIs. So this is exactly correct. And again, this is was a proof to us that Bridge IT is good at the log analysis as well. So at this point, it's also important to remember, and you probably heard this multiple times in the sessions from this conference, that there are some limitations here. The outputs from the LLM, they are not always the same. And they're not always the same because by default, the temperature parameter that measures the randomness or creativity of the model, it's not set to 0. So we want, once we get programmatic access to this service, and we are expecting to get it very soon, we want to be able to do these tests with 0 temperature, means 100% deterministic. and to see what is the performance of that. And we also have limitations in terms of the context size. We are still working here with 8,000 tokens. So if we have access to more, we will be able to provide bigger log messages and bigger data as well. So bigger time range of data to be analyzed. So we have these limitations, but Sam Altman, CEO of OpenAI, just 4 weeks ago said that ChatGPT-4 is the dumbest model that any of you will ever have to use again. So this gives us a good hope that what's coming next will probably come soon and will come much better. And already last week we had the announcement of ChatGPT 4.0, and there were some demos on the capabilities of data analytics. So we expect to leverage that and to integrate that here into our solution to extract value from it. All right, so we are reaching the end. So summary and key takeaways. For us in Do Automation, it was very important. The investment in monitoring and observability really enabled proactive maintenance and fast troubleshooting. So a lot of value extracted here from us, for us. Also very important to remember that adopting Prometheus for monitoring and Loki for log aggregation required a small effort and a large delivered value. It was a simple solution. There was no coding, no new servers. It was just configuration. We deployed this open source services, and they were just working and delivering value to us. And we want that. Regarding Bridge IT, we understood that it has good capabilities of both data and log analysis, and we are expecting future LLM versions to be even better, and we want to use that. And finally, just to remind you again that we see this observability has a journey, and we're just starting it. So thank you, and let me know if you have any questions.
Hi, Telmo. I know most of the topics, of course, but I have a question that just came to my mind. Do you think that LLM can expect or forecast what could happen in the future? I mean, if we ask him about what is the possible trends or what could happen based on this information, do you think that this is doable?
Good point. Actually, when I was doing some of the tests, and when I was looking here at the red line, I tried to understand. I tried to ask the question if we could predict, since it can detect periodicity and trends. I was asking further questions. Can you tell me what's going to happen next? Right. So this forecast capability, I tried to test it. It was not successful. I did not get the result that I wanted, or it was not telling me that it will grow. It will pass 300 after 3 weeks or something like this, or after an hour or so. But I would also say that in this process of prompt engineering that I was testing, in many situations, I was getting negative responses. Sometimes even the LLM telling me specifically that, I'm not a data analysis tool. You cannot give me a CSV file. You need to do some Python scripting to do that analysis. But then you ask it in a different way, and it actually reveals that it has those capabilities. So I think there's still potential for that, and maybe on the new systems with 4.0, for example, it will be able to do that better. Yeah. So we are waiting hoping for that too. Yeah. Thank you. Thank you.